Hello everyone. In this video lecture, we will take a couple of example problems to understand source-free RL transients. So before going to the example problems, let's take quick recap of the source-free RL response. So in the last video lecture, we derived the current flowing through the inductor I of t is equal to I naught into e power minus RT divided by L. So there are three constants present in the equation. One is I naught and resistor R and inductor L. So let's recall what is I naught. I naught is called as initial current, or I can say current flowing through the inductor when the circuit is changing from forced response to source-free response. And R is the equivalent resistance or the net resistance present in the RL circuit, and L is the equivalent inductance or net inductance in the RL circuit, and T is the time. So if you are able to calculate all the three parameters, namely the initial current, equivalent resistance and equivalent inductance, then you should be able to get the inductor current in the source-free RL circuits. So always remember this equation and understand how to get the values of I naught, R and L from the given circuit. Then it's very simple for you to analyze the source-free RL response. So if you simplify this equation I of t in terms of the time constant, so time constant is given as L by R. So we have a new constant defined as time constant and value is equal to L by R. On substituting tau into this equation, we have I of t is equal to I naught e power minus t by tau. So basically this time constant provides or determines the rate at which the current or voltages approaches to zero. Right? So please understand that this R and L is not a, if you consider only one resistor and inductor, then you will have R and L. If you have multiple resistors, multiple inductors in circuit, then this R should be replaced by R equivalent and L should be replaced by L equivalent. That's all. Right? So from the last slide, we understood that the current flowing through the inductor is equal to I naught into e power minus RT divided by L. So from the knowledge of current I of t, we should be able to calculate other parameters such as voltage across a resistor or power dissipated in the resistor, or still the voltage across the inductor and power dissipated in the inductor. So all other parameters can be easily derived from the knowledge of the current I of t. So I of t or calculation of I of t is a prime factor in analyzing source-free RL circuit. So with the basics, let us consider the example problem. For the circuit shown in figure, find I naught for t is greater than 0. So before analyzing the given circuit, you have to understand what is the type of circuit given to you and what is the type of analysis to be performed. So basically we have three types of circuits in DC transient analysis. One is RL circuit, second one is RC circuit, and third one is RLC circuit, right? Then what are the types of analysis we have? We have two types of analysis. One is source-free analysis and second one is forced analysis. So for the given problem, the type of the circuit comes under the category of RL circuit, right? So we have only resistor and inductor. So we can say the type of the circuit is equal to RL circuit. And what is the type of analysis to be performed? Whether it's a source-free analysis or forced analysis or combination of forced and source-free analysis. Since you are asked to find the current I naught for t greater than 0, what is the circuit condition for t greater than 0? So when t is less than 0, as per the circuit condition, when t is less than 0, the switch is closed, right? So when t is less than 0, the switch is closed. So current will be flowing through your mesh 1 and mesh 2, and definitely the current will be flowing through your inductor. So when you at t is equal to 0, you are opening the switch. At t equal to 0, you are opening the switch. Then you are disconnecting the RL circuit. You are disconnecting the RL circuit from the supply voltage. So at t is equal to 0, the circuit is open. So our interest is to find the current flowing through the inductor or current I naught for t greater than 0. For t greater than 0, we have only R and L combination, and there is no source present in the circuit. So we can say it's a source-free analysis. Alright. So the type of circuit is RL circuit, and the type of analysis interested is source-free analysis. Right. Since the analysis to be performed is a source-free analysis, we know that the current flowing through the inductor during the source-free condition is equal to I naught into e power minus t into R by L. Right? So we know that the current flowing through the inductor during source-free condition is equal to I naught into e power minus t R divided by L. So we need to find the value of the constants I naught, R and L in the given circuit. So what is I naught? I naught is the initial current or current flowing through the inductor when the circuit is changing from forced response to source-free response. When the circuit is changing from forced conditions to source-free condition. And R is the equivalent resistance in the network, and L is the equivalent inductance in the network. Right? So let's find the value of I naught. So I naught is a current flowing through the inductor when the circuit is changing from forced condition to source-free condition. So for t less than 0, when t less than 0, the switch is closed. Alright. So when t is less than 0, the switch is closed. So we have circuit for t less than 0. So if you analyze the circuit, so when t is less than 0, the inductor will act as a short circuit. So replace inductor by short circuit and do the analysis, either mesh analysis or simplify the network and find out the current flowing through this branch. Find out the current flowing through the inductor. So you should be able to get the current flowing through the inductor by any of the circuit analysis techniques. Right? So if you calculate, you will get 1.2 amperes. That is your initial current or current flowing through the inductor when t is less than 0. Now at t is equal to 0, you are opening the switch. Once you open the switch, you have only a resistor and inductor in the circuit. There is no source, right? For t greater than 0, we have a source-free RL circuit. We need to find the value of L and R. L, we have only one inductor, so the equivalent inductance would be 4 Henry, and we have two resistance. We have two resistance present in the circuit, so we need to find R equivalent of the circuit before proceeding on substituting into the equation. So how do you find the R equivalent? Across what terminals you will find the R equivalent? So basically you need to find the R equivalent across the inductor terminals. So assume that you have an inductor here and the terminals are A and B. So what is the equivalent resistance across the terminal A and B? So across the terminals A and B, you have series connections of 4 ohms and 8 ohms. So R equivalent is nothing but 4 plus 8, which is equal to, the time constant is equal to 1 by 3. So substituting into our generic equation, that is I naught into e power minus R into t by L, you will have 1.2 e power minus 3t amperes, right? Okay, let us take the next problem. The switch in the circuit shown in figure has been closed for a long time. At t is equal to 0, the switch is opened. Calculate I of t for t greater than 0. Right? So we need to analyze, or we need to understand the circuit in different time regions. What is the circuit condition when t is less than 0, and what is the circuit condition when t is equal to 0, and what is the circuit condition when t is greater than 0. So when t is less than 0, as per the problem, the switch is closed. The switch is closed and kept long time for under t less than 0. Right? So when the switch is closed, you have a voltage and the circuit is closed, and current will be flowing through your 4 ohm, 12 ohm, 16 ohm and 2 Henry elements. Since the circuit is kept for a long time, your inductor will act as a short circuit. Am I right? So for a DC voltage, the impedance offered by the inductor is equal to 0. So hence your inductor will act as a short circuit, and there will be a current flowing through the inductor. So this is the condition for t less than 0. When t is equal to 0, you are opening the switch. When t is equal to 0, you are opening the switch. So you have only resistor and inductor combination, and we are interested to analyze a circuit for t greater than 0. So after you open the switch, how inductor supplies the current to rest of the components, how the inductor current reaches 0 from its initial value, right? So before proceeding on the analysis, again you have to recall what is the type of circuit given to you and what is the type of analysis to be performed. So the type of circuit given to you is R and L. So we can say it's a RL circuit, and the type of analysis is t greater than 0. So at t greater than 0, we don't have any source in the circuit, so we can say it's a source free analysis. So this analysis comes under source free RL circuit. So after after confirming that it's a source free RL circuit, then we can apply the equation, that is I of t is equal to capital I naught into e power minus t R by L. Right? So this equation is valid for a source free RL circuit. Alright. So we need to find three parameters, namely initial current I naught and the equivalent resistance R and equivalent inductance L. So to find out the current I naught, you have to find, so I naught is nothing but your initial current. To find the initial current, you close the switch. After closing the switch, the inductor will act as a short circuit. You find out the current flowing through the inductor when the switch is closed position. So when t is less than 0, the switch is closed and the inductor acts as a short circuit to DC. So you are seeing a short circuit is in parallel with 16 ohm resistor. So the resistance of the short circuit is 0. So 0 is in parallel with 16 ohm. So the equivalent resistance of this parallel combinations becomes 0. So you have reduced circuit as 40 volt, 2 ohms and 12 ohms and 4 ohms. So this is a short circuit. Basically you have your inductor here. So inductor is present but it's acting as a short circuit. We are interested in finding the current flowing through the inductor, right? That is your initial current. So to find out this current flowing through this inductor, you can apply any of the circuit analysis technique like mesh analysis or nodal analysis or KVL, KCL. So any circuit analysis technique can be applied and find out the current flowing through the inductor. So one such technique is finding out the equivalent resistance and applying like voltage division rule or current division rule. You can identify the current flowing through the inductor as 6 amperes. right? So you are replacing this parallel combination by its equivalent resistance, that is 12 ohms in parallel with 4 ohm, which is replaced by 3 ohm resistance. Now we have 2 ohms and 3 ohms in series. So then you are finding out the total current, that is current I1. Current I1, that is total current supplied by the source, is equal to 8 ampere. So 8 ampere current is entering here. So having 8 ampere current to this node, what is the current flowing through the 4 ohm resistance? So this is our inductor current, right? So what is the current flowing through the 4 ohm resistance, or I can say what is the current flowing through the inductor? So 8 is the total current. So you can apply current division rule to find out the current flowing through this inductor. So by applying the current division rule, you can say 6 amperes. So 6 amperes is flowing here and remaining 2 amperes is flowing this side. Okay. So our initial current is equal to 6 amperes. Since the current through the inductor cannot change instantaneously, we can say I of 0 is equal to I of 0 minus. So this 0 minus represents just before t is equal to 0. So generally we will have 0 plus and 0 minus in the transient analysis. So 0 minus represents just before t is equal to 0, and 0 plus represents just after the t is equal to 0. Since inductor cannot change instantaneously, so just before t is equal to 0 and at t is equal to 0, both values are equal, which is equal to 6 amperes. Now our interest is what is the value of the current when t greater than 0. So when t is greater than 0, the switch is open and the voltage source is disconnected. So your voltage source is disconnected. So now we have only source free RL circuit. So to find out the value of R equivalent, find out the equivalent resistance across the inductor terminals. So go to this circuit, find out the, so now this is our RL circuit. So identify or calculate the equivalent resistance across the inductor terminals. So you need to find the equivalent resistance across the terminals A and B. So looking at the terminals A and B, you have series connection of 4 ohms and 12 ohms. So this series connection is in parallel with 16 ohms. So we can say 4 plus 12 is in parallel with 16, right? So your equivalent resistance is equal to 4 plus 12 is parallel with 16 ohms. So by simplifying that, you will get 8 ohms as the equivalent resistance. Then you have only one inductor present in the circuit. That value of the inductor is equal to 2 Henry. So find out the time constant or the value of L and R equivalent. So the time constant is equal to 2 divided by R equivalent. So your tau is nothing but 1 by 4 s. Substituting the value of tau into the inductor current equation, we have I of 0 is equal to 6 amperes and tau is equal to 1 by 4. Substituting, you have minus 460. So the inductor current is equal to 6 into e power minus 40 amperes. So I believe you followed the class. Thank you very much.